Well, welcome. In this video we're going to be looking at Lesson 2.4. And you can see the objective here for Lesson 2.4 is all about understanding what the rate of change is and how we can apply that to our direct variation equation that we've already talked about. Remember, direct variation is in the form y equals k times x. So let's first start out by making sure we understand what is the rate of change, because you may not even recognize it, but you're probably already familiar with what a rate of change is. Because rate of change is the same as the slope of a line. And this is all defined for us here on my left. So we can see that, again, the rate of change is the same as the steepness of a line. And the slope of a line is the same as the rate of change. And we're going to be using coordinates on the graph to determine what the rate of change or what the slope of that line would be. So let's look at this box here so we can see how we can determine what the rate of change is. So again, you're already familiar with slope. So remember, slope is the same as the rise over the run. So if you're looking at a graph, we can determine the rise by how far up or down the graph is changing from one point to the next. And the run would go in the denominator. That's referring to how far from the left to the right the graph is going from one point to the next. And just as a reminder, we read a graph just like we read a book, from the left to the right. Now, the rise over the run is the same as the change in y in the numerator over the change in x in the denominator. And remember, we have a formula to help us express that, and that formula is y2 minus y1 divided by x2 minus x1. And that gives us our slope, and remember, the slope is the same as our rate of change. So if we're working with the story problem, and the story problem asks us to find the rate of change, now you know it's the same as finding the slope. So let's look at this box here on my down to my left here, and then let's look at some problems so we can see how we can apply what we've just talked about. Okay, so this box tells us that the graph of the direct variation function, remember that's in the form y equals k times x, has a constant slope k. Now you might be saying, wait a minute, I always thought that the slope was m. Well, going into chapter 3, that is what we'll be learning about. But for this portion, so for what we've talked about so far, when we're dealing with direct variation in the form y equals k times x, k is the same as your slope. Because if you remember from the equation, you're probably thinking of y equals mx plus b. M is just a number that's being multiplied times x. Well, guess what? K is taking the place of that m. It's the same thing. So m represents the slope. In this case, k also represents the slope or the rate of change. So for these two examples, they're pretty easy. When you look at this first one here, it says determine the slope of a line with the equation d equals 1/5 t, where t we can see would be the independent variable for time, and d would be the dependent variable for distance in miles. So for this situation, to find the slope would just be then the 1/5. So once you look at the next equation, you can probably determine really quickly what the slope would be. And if you're saying, well, this is easy, the slope is 5/7, guess what? You are correct. So let's look at some other problems here. These two don't give us an equation, they give us two coordinates. We want to find the rate of change between those two coordinates. So remember the formula for rate of change, or to find the slope, is where we find the change in y, the y2 minus y1 over the x2 minus x1. So when I look at these two coordinates, my 5, 8 and the 3, 12, you might be wondering, well, does it matter which one I use as my x1 and y1 and my x2 and my y2? And I'm going to show you that it does not matter as long as we are consistent. So let's say, for example, that we use the 5 as our x1 and the 8 as our y1 and our 3 as our x2 and our 12 as our y2. So if I take my y2 minus y1, I would have 12 minus 8 in my numerator. In the denominator then, if I'm consistent, which I need to be, I would take the 3 minus 5. Now I want to simplify that. 12 minus 8 would be 4. 3 minus 5 would be a negative 2. We always need to reduce or simplify, so 4 divided by negative 2 is the same as negative 2. So that would be our slope. Or if you said negative 2 over 1, that would be acceptable. Now, what if you had treated it differently? Let's say if instead of doing 5, and 8 as our x1 and y1. Let's say if we switched it around. So we could do it this other way, and you'll see that you still get the same answer. So if I took 8 minus 12, now I need to be consistent though. If I took the 8 minus a 12, I would need to take the 5 minus a 3. And watch what happens. 8 minus 12 would be a negative 4, but 5 minus 3 would be a positive 2. So when we simplify that, again, you end up with negative 2, which is the same as what we had originally. So you don't have to do it both ways. You only have to pick one way, but I just wanted to show you that it does not matter which coordinate you pick as your x1 and y1 and your x2 as your y2. As long as you're consistent, you'll end up with the same answer. So why don't you try this next one on your own, where we have these two coordinates, the negative 2, 5, and the 7, 11. So why don't you take a minute, pause the video, and hit play when you're ready to check to see if you have the correct answer. Okay, let's see how you did. So you should have started out one of two ways. Now the way I did it is I took 11 minus 5 in the numerator and 7 minus negative 2 in the denominator. And I got to be careful with that. Now the 11 minus 5 we know would be 6. 7 minus negative 2, you have to remember, is the same as 7 plus 2, which would be 9. 6/9, even though we can't take 6 divided by 9 and get a nice integer number for our answer, we do want to reduce that. If you left it as 6/9 on a quiz or a test, you will lose points for not reducing. So please make sure to reduce. So when I look at this, I see that both the 6 and the 9 are divisible by 3. So that reduces to 2/3. So hopefully you got that. Okay, so that's all about the steepness of a line or the rate of change. Let's take a minute to talk about the graph of y equals k times x. Now before we take a look at these graphs, I want to make sure that you understand the quadrants for our coordinate plane. So if you notice up here in the top right corner of our grid, we have quadrant 1. That is where both the x and y are going to be positive. Now we go counterclockwise. So the next quadrant is quadrant 2 is on the left. That is where x is negative, but y is still positive. Again, continuing in a counterclockwise manner, we would move to quadrant 3. That is where both x and y are negative. And then we end over here in quadrant 4. Quadrant 4 is where x is positive again, but y is still negative. Now we're going to have two examples here. We're going to have one example when k is positive and another answer when k is negative. When k is positive, the graph is going to be increasing from left to right. So as k increases, y is going to be also increasing. Over here on the right, when k is negative, so in other words, when we have a negative slope, the graph moves downwards from left to right. So you want to make sure that you understand that when k is positive, the graph is going to be in quadrants 1 and 3. When k is negative, it's in quadrants 2 and 4. Let's look more about that value for k and talk about how does that k affect the graph. And to help us out here, to illustrate this, I have on my graphing calculator what we call a slider that's currently being animated here. So let's look at what we have going on. So here we have our equation, y equals k times x. And if you notice, what this slider is doing is it's inserting values, different values for k into our equation. And it's graphing it so we can see how those values of k are affecting the graph. So take a minute and watch this animation. And look at our values for k. As our values for k are increasing, let's look to see what's happening to the graph. So again, we can see that as the values for k are increasing, the graph is getting steeper and steeper. And here, when it cycles back to where k is smaller, you can see that it's closer to the x-axis. So it gets more horizontal. Let's summarize this in our notes. So for example, let's say if I had this graph or this graph. Later you're going to be asked to tell which graph would match to a certain equation. So if we had the difference between y equals 2 times x and y equals 1/2 x, you'd have to know which graph would relate to each equation. So remember, this first one, this red graph, would represent or could represent y equals 2x because that's steeper than the line y equals 1/2 x because it has y equals 2x has a larger value for our slope or for our rate of change. So let's summarize what we've just found over here in this box. So the larger or further away from 0, or k, becomes, the steeper or more vertical the line becomes. Or the flip side of that is we could say the smaller, the closer to 0 k becomes, the flatter or more horizontal the line becomes. So it's really important to understand that because, like I said, later on we're going to be matching graphs to equations without being able to use a calculator. So it's really important to understand this concept that the larger that our value is for k, the steeper the line is going to be. The smaller our value for k is, the more horizontal the line is going to be. And also just remember that when k is negative, it causes that graph to flip instead of being in quadrants 1 and 3 to be in quadrants 2 and 4. So hopefully after watching this video you have a better understanding now of rate of change and how it relates to slope. And we have a better understanding of how that slope or rate of change affects that graph for our direct variation. So with that, good luck now as you work on your assignment.